So a householder has 6 laying hens and wishes to construct a rectangular enclosure to provide a maximum area for the hens using a 12-metre length of fencing wire. Construct the function that will give the area of the enclosure, A, in terms of its length, L. And then by sketching the graph, find the maximum area that can be fenced. So ultimately we're looking for the maximum area here. But in the actual question, we're given 12 metres of fencing wire. So we're not talking about area there, we're talking about perimeter. So how do we relate all of this information together? Well, let's start off with the fact that we have got a rectangular enclosure with 12 metres of fencing. So first of all, we draw our rectangle and we know that the length and the width are the dimensions of our rectangle. We also know that we have 12 metres of wire and that goes all the way around. So we're talking perimeter there. So we know the perimeter of our rectangle is 12 metres. Well, let's link the length and the width together. We know that the length plus the length plus the width is equal to 12. 2L plus 2W is equal to 12. And I'm going to get width in terms of length, and I'll show you why in a minute. So 2W is equal to 12 minus 2L, and W is equal to 12 minus 2L divided by 2. We could take out a common factor up the top there, and we get 6 minus L. That's what our width. Now, ultimately, the question is asking about area, okay, to find the maximum area. So what do I know? I know that area is equal to length times width. And of course, I can't do anything at the moment. The question does ask me to construct a function that will give the area of the enclosure in terms of L. Well, I don't want the W in that rule, but I do know that W is equal to 6 minus L. So A is equal to L outside of 6 minus L. You can leave it like that, or you can expand it out. 6L minus L squared. Now we need to sketch the graph and find the maximum area. Sketching the graph, obviously it's a quadratic, and we've already got it in factor form. So when A is equal to 0, we're going to get L equals 0 and 6 minus L equal to 0. So 6 minus L is equal to minus 6. L is equal to 6. They are our x-intercepts. So 0, 0 and 6, 0. Now remember, area cannot be negative, so we can't go underneath the x-axis or the L-axis. And length cannot be negative, so we can't go in the backward direction. So what this actually tells us now is, because it is a quadratic and it is upside down, because we have a minus L squared, that our turning point is going to be when L is equal to 3. So when L equals 3, A is equal to 6 times 3 minus 3 squared, which is 18, take away 9, which is 9. Now this is what our graph looks like. The only other things we need to put in there are open circles at either end there, because if L was equal to 0, then our area would be 0. Or if L was equal to 6, our area would be 0, and we wouldn't have a rectangle. So we can't equal those two values. This point up here is when L is 3, is equal to 9. So that is 9 metres squared. That is the maximum area of the rectangle.